Okay, in this video, we will be solving 3 basic stoichiometry problems. So the first one is a recipe calls to use 5 apples to make 1 perfect pie. And we have a total of 46 apples, and we want to know how many perfect pies can be made. So we have 46 apples, and we know that 5 apples are required to make 1 perfect pie. 1 perfect. And so if you notice here, apples and apples cancel, and we're left off with perfect pie. And so if we were to use a calculator, 46 divided by 5 would be 9.2. Now, we're dealing with an actual thing, and an actual perfect pie requires 5 full apples, and so the number of perfect pies that can be made would be 9 perfect pie. You can't have a partial perfect pie. And so this is the first problem, very basic. So in this second problem, it's more of a chemistry problem. You have 300 grams of butane, which is being burned. We want to know how many grams of H2O was produced. And the equation for burning butane is here. A side note, molecular weight of butane is 58.124 grams per mole. Simply, you have the molecular weight of carbon is 12.011 times 4, because you have 4 of them, plus hydrogen, molecular weight is 1.008, and you have 10 of them. This 12 and the 1.008 came from a periodic table. And likewise, H2O molecular weight is 18.015 grams per mole. And so the problem is asking us to determine the number of grams of H2O. And so first, we know we have 300 grams of butane, C4H10. From there, we need to convert this grams into moles, because this right here is a mole ratio. So we know that 58.124 grams of butane, C4H10, is equal to 1 mole of C4H10. From there, we know that 2 moles of butane is equal to 10 moles of H2O. So we say 2 moles of butane, C4H10, is equal to 10 moles of H2O. Now this problem is asking us to know the number of grams. So we need to convert from moles to grams. We know that 1 mole of H2O is equal to 18.015 grams. 18.015 grams of H2O. Now let's just check. Does our stuff make sense? So grams of butane cancels. Moles of butane cancel. Moles of H2O cancel. And we're left off with grams of H2O. And we want grams of H2O. So using a calculator, if you multiply everything and divide by everything, you would get 464.9 grams of H2O and significant figures. So this is 300.0, so 4 significant figures. This right here is 4 significant figures. And so this is the second problem. Now we'll do the third problem. It's a dilution. So you want to produce a 250 milliliter of 5 molar solution, but you only have a 10 molar stock solution. You want to know how much in milliliters of the stock solution, the 10 molar solution, do you need to produce the desired 250 milliliters of 5 molar solution. And so with this problem, we don't even need stoichiometry, but we'll solve it using stoichiometry. But first, we'll do a shortcut for dilutions only. And the shortcut is C1, concentration 1, times volume 1 is equal to concentration 2, volume 2. Concentration 1 is what we know. And so concentration can be, molar is moles over liter. So that's a concentration. So you can write 5 m times v volume is 250 mil. Now, this is a liter, this is a mil. It's okay in this case, if you're using the shortcut, to kind of ignore this difference, because the other one also has the same problem. The other one also has the same problem where you're dealing with molarity and you're dealing with mils. And so here you have 10 molar, and you want to know X in milliliters. So you do 5 times 250, you would get 1250. 1250 divided by 10, and so you would get 125 mils of the 10 molar stock solution. Now, let's solve this problem using what we did earlier with stoichiometry. Ignore this shortcut rule. So let's solve this problem using stoichiometry. And we can do that. It's a couple more steps. So first, we want to produce 250 mils. And this is where I'm going to start. I'm going to start at the 250 mil. We know that 1,000 mil is 1 liter. From there, we will use this 5 molar solution. We know that 1 liter of solution would contain 5 moles because big M is 5 molar, which is 5 moles per liter. And so from here, let's check what we have. Mils cancel, liters cancel, and we have just mole. So we would get 1.25 moles. That's the number of moles that we need. Now in our case, we have a 10 molar stock solution. And so we can start from here. We have 1.25 moles. That's the number of moles we need. And we know that 10 moles, our stock solution, 10 moles would equal 1 liter. And we already know that 1 liter is 1,000 mils. So we can just write 1,000 mils of the solution. And so now we multiply it out. So you would get 1.25 times 1,000 divided by 10, and we would get 125 mils of the 10 molar stock solution. And that's all we need to do for these 3 problems.